All right. Is it picking up my voice? Hold on. Let's make sure it's picking my voice. Okay. All right, guys, let's get going here. All right. So what you want to do, guys, just quiet, please. The first step, you want to factor if you can. So notice I'm factoring, right? So I'm picking up in the middle of the page, the middle of the part 4 of the notes. And it's still more factoring I could do, right? Still more factoring I could do. All right. And if you guys can just please be quiet, that'd be great. I know I gave you guys 10 minutes to be a little rambunctious. That's my fault. But anyway, if you guys can give me your attention, it'd be awesome. So yeah, so you got that, right? So always factor first. Break down those factors as much as possible. And you can see like right here, even says so as well, like factor is the first step. And then try to see if anything cancels. Anything cancel here? No, right? If things do cancel, there'll be holes. I'll have a simplified form, but nothing cancels. So we're okay in that regard, okay? Then what I would do is I'd find these items. I'd find the x-intercept. I'd find the y-intercept. I'd find vertical asymptotes, horizontal or slant asymptotes. And I would do a sign chart. And then I'd graph it. I kind of call it a 6-step process. I guess technically 7 or 8 steps, because I guess before you do these things, you should factor, you should simplify as well, which I take care of, right? Nothing simplified, of course. Back after yes, but this helps me do these items. These are the characteristics of the graph. This can help you make a very accurate graph. We'll check if this one. X-intercepts should be pretty easy. What are the x-intercepts here? Yeah, good. The y-intercept, I actually look at the original. That might be better. If I plug 0 into the original, what do you get? 1/2. So let's plot that 1/2. 1 and -1. Okay. Okay. We're doing it right. Vertical asymptotes, what makes the bottom 0 after you simplify it. So plus minus 2, x equals, remember it's an equation. Thank you. So we got that. We got that. Now the horizontal asymptote, we have to consider the cases, right? There are 3 cases. The case when the bottom has a higher degree than the top, the case when the bottom and top have the same degree, or the case when the top has a higher degree than the bottom. That third case, when the top has a higher degree than the bottom, won't be horizontal asymptote, because as x gets bigger, the function gets bigger. In that case, you have to do a slant asymptote, hence polynomial division, either longer or synthetic, depending on what you got. But the degrees are the same, right? And when the degrees are the same, what do we do? You do what, sorry? The ratio of the leading coefficients, yes. Y equals 2, perfect. Thank you, Adi. I know those who chimed in. Okay, so now you kind of got the foundation of the graph. We got 3 points, right? And let me make these dots a little more noticeable. Let me switch colors just a tad. Let's make these dots a little more noticeable. Oh, I meant to switch colors. Here we go. Yeah, let's make it a little more noticeable, right? Okay. Now, the sign chart, I usually like to do the sign chart right below the graph because it kind of is tied closely. It's kind of tied closely. Not kind of, it is tied exactly to the x-intercepts and vertical asymptotes. Because remember, these values that make each factor 0 are going to be on the sign chart, right? These are values of the sign chart. They're going to cause sign changes and go top to bottom. And that's when you see, well, y equals positive, negative, blah, blah, blah. And here's what I like to review. So some of you guys might try to test each, test the number in each interval. I can take 5 intervals, 1, 2, 3, 4, 5. What I'd like to do is start at the rightmost interval. So obviously the rightmost interval starts at 2, right? Let's put in our bigger instead of 3. I put in 3. Positive, 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 positive. So 2 is positive. That's not positive. That's not positive. That's 2 positive. That's 2 positive. Bunch of positives, right? So clearly, my interval is positive here. Now, every factor, is it linear? Is it quadratic? What can I say about every factor here? Is there any exponent-sensitive factors at all? No. Every factor is linear. When that happens, you have the luxury of alternating signs. The only time the sign would not change is when one of the factors has a square or even exponent next to it. We don't see that at all. So you can just do a simple alternation. So you're being somewhat critical here and efficient. Like, could I test it 1.5? Sure. But why? Could I test it, 0.5 or negative 1.5? Sure. Not necessary. Once you get the rightmost interval figured out and you know what each factor is doing, you have deep intimate knowledge of the function, you don't have to waste time testing values in each interval. You can do alternations as you see fit, right? Or as this should happen. Now, in this case, now I know what to do. Now, should I plot some points in the far right and far left intervals? Yeah, I should. I should like plug in 3 and see what happens, plug in 4 and see what happens. Or plug in -3 and -4. But I know this curve has to be above or else not to. If it's below, there's gonna be a few issues. First of all, it's below, you got another x-intercept you're not supposed to have. Also, the other issue is you're gonna have some values that are negatively divided too, which you're not supposed to have either. So this is kind of this nice safety net. It kind of confirms, reaffirms you can do this correctly.
So how do you know whether like without like whether it goes down and stays under the asymptote or stays under the asymptote?
Great question. So you're not. So I think if I understand correctly, you're asking this. But what if it kind of like decided to do something like this, like that? So you're asking that.
It's like
That's we'll cross that bridge. We'll cross that bridge. Yeah. We're getting this in your ones. We'll cross that bridge we get. But typically these kind of functions where you have 2 vertical asymptotes and everything, nothing cancels. There's nothing weird. Like there's no slant asymptote. It's going to be very typical like this. I mean, I guess we could do UVs. You could technically plug in. Sure. Then I guess I'm going against what I'm saying. Like, what if you plug in 10 and see what happens? I guess, but yeah, there's a graph. And I would ask you for domain. I think domain is fair because domain's all real except -2 and 2. The range might be a little tricky. And the reason the range is tricky, I haven't taught you guys how to find extrema analytically. We do that in calculus. And even then, we do some calculus this semester. We don't quite get to that part of calculus. You guys won't get to that until next year. But like, I'm pretty sure this is the high point, but there's a way to analytically prove it that's using calculus, using derivatives. I haven't taught you guys that yet. So we're going to avoid giving the range for this. But domain's easy. Domain's all real except -2 and 2. So, all right, let's keep moving, guys. All right, now this one's kind of a fun one. And what I'm going to do is get rid of all the junk. Keep all the things here because I need it. All right, so that's like a little template. Again, just rinse and repeat. Let's factor. Let's find the stuff. So you guys should be pretty adept with factoring by this point, right? Factor on x. What's that going to be? X plus 2, x minus 1. And x minus 1's cross off. So you got this now, right? So there is a hole. And I'm gonna figure out the hole first. The hole is at 1 comma what? What would you guys say? Where would the hole be at? 1 comma what?
1 comma.
You substitute 1 to the simplified form. 1,5 actually. Sorry, 5/3. My apologies. 5/3. So the hole occurs when the factor cancels. Factor cancels. So you know it's going to have that 1 because not a vertical asymptote, not the hole. The vertical asymptote has to be a limit, right? That has an infinite output. The limit as x approaches 1 to the left, 1 to the right, we go for positive infinity for a vertical asymptote. It's not. It's a hole. In fact, actually, the limit's 5/3. Because if I were to approach 1 to the left or right into the original function or to the simplified form, I get 5/3. So I put 1 to the simplified form, I get 5/3. How do you do it?
So do we just put that point as like a circle?
Yes, 100% correct. You can put an open circle right here. Like that. Totally. Actually, do in blue. So I got that out of the way. Okay, x-intercept's easy, -4. Y-intercept, there is none.
Yeah, in fact, we have a vertical asymptote here. And we have another vertical asymptote at -2. Okay. And -4. Here we go. Hold on. I'm just off today too. There we go. Okay. What's the horizontal asymptote, guys? Y equals 0. Now, my graph is going to cross the horizontal asymptote, and that's okay. That's totally okay. That totally could happen. We are going to cross it. Then I'll do a sign chart because sign chart is going to help me be more accurate. So we only look at what makes both top and bottom 0 after it's simplified. So totally at -4, totally at -2, and totally at 0. So if I plug in something bigger than 0, yeah, everything's positive, right? And all the factors are linear. So it's an alternation. Yep. So I'm probably gonna have something like this. Positive. I'm sorry, say it again. Am I plugging 1? 0. No, I simplified it.
I'm plugging like 5 What? 5 over 1 section. Oh, so you're starting to. Yeah, dude, you can't because you're divided by 0. You can't plug it here. Okay, so when you have this whole, you gotta plug the simplified one.
Gather is probably gonna kind of look like this. Now, granted, it could do something funky like this. So you answer your question, like what's probably happening. I don't know, actually, because I had to do some calculus. But I'm just gonna kind of guesstimate a little bit. Maybe it looks like that, but it's got to go towards 0 anyway. And then here, I guess I will plug in -1. If x is -1, what's y gonna equal? Should be 3 over -1 should be -3, I think. Probably something like that. So yeah, that one's a little funky. It's good to do funky ones. Yeah, Cap. Okay, good.
Do you know, like, -1, -3 for the text, or is that just?
We don't have calculus. Yeah, I'm gonna kind of gather it will because it's kind of right in the middle. But let's find out. I don't know. Yeah, when you get the calculus, you start doing things way more accurately. But yeah, y equals was x squared plus 3x minus 4. Is that correct? And then x cubed. Can someone help me out? What was x cubed plus x squared? Thank you. Yeah. Let me just clear my drawings for a moment. Yeah. Actually, the high point was not -1, 3. It's close. So you have to use calculus for that. Yeah. And you can see how like it does dip a little bit. See how y is getting smaller, all of a sudden it starts rising. It's just getting closer to the x-axis. So there's a little dip there. And you're not gonna be able to find that because again, you haven't learned calculus. But our graph for the most part is fine. So okay. Okay, let's do one with a slant asymptote. All right, here we go. That's a terrible looking 2. What happens to those x minus 2 is cancel, right? Yes, sir. Totally, yeah. 100% it is. You thought right. Good. And the hole. Where's the hole, guys?
Yeah, so 2,
2, 3. Excellent. Good. Good. And slope of 1, obviously.
2, 2, 3. When you get 0 on the top, if you plug 34.
No, but it'll be 0 on the bottom also. Yeah. So it's just graph x plus 1. And technically that is a slant asymptote itself, because you did do the division. So yeah, it's pretty easy. That's an easy one. The asymptote would be at y equals x plus 1. Yeah, it'll be a slant asymptote. It just so happens they coincide. Because remember, what is a slant asymptote in the first place? It's end behavior, right? How does end graph behave? It looks just like x plus 1 fact. It's identical. X plus 1. All right, let's keep moving. All right, this one's very factor for us. So that's very nice. But things do cross off. So whole. Whole's gonna be at -1 comma something. You guys have an answer? -1 comma 4. Let's confirm that. So you have 2 times -3 times -4 over -1 times -6. So you have 24. Yep, I agree. Good. Good. Excellent. So yeah, you have 24 over 6. Totally agree. That's straight up 4. Okay. X-intercept. Crap, I deleted the template. That's okay. 2 and 3. Y-intercept. Y-intercept should be, let me think here. -6. Should be 12 over. Oh, you can't do it. There's none. Sorry. Yeah, it's not because you can't divide by 0. Sorry about that. VA is x equals 0, x equals 5. HA does exist. What are the degrees about top and bottom? So y equals 2. And x equals 0, x equals 5. Okay. X-intercepts. Sign chart. All right. And then, yeah, as I said, let's test the rightmost interval. If I plug in 6, everything's positive, right? Should everything alternate? Right? Everything should alternate, right?
Yeah, we can solve.
Yeah, good. So yeah, here we go. It's gonna a little bump up, right? That's terrible. That's why I need a stylus. Yep. There you go.
Should we plug the hole? Oh no, we don't plug.
Oh, I didn't plug the hole in. Sorry. No, you are correct. I do need to plug in the hole. Thank you. Thank you. No, I forgot to do that. There we go. My bad. Yep. So domain's all real except -1, 0, and 5. Right. And again, I'm not gonna ask for range. I don't know how high that middle part's going, so okay. We still haven't done any synthetic division yet, and now we get our chance. We get our chance. Okay, let's look at this one here. Cancel. Hole. Where's the hole, guys? -3/2. Good. Yeah, I can't do 3, sorry. Okay. X-intercept at 2. Y-intercept's gonna be at -4/5, I think. Is that right? Minus the -4/5. Yeah. Good. Good. The VA is x equals 5. HA or slant A. It's gonna be a slant asymptote for sure, right? Okay, we're gonna have to do. I'm gonna do synthetic division because I don't like long division. So what did I just do? I took x minus 2 squared and expanded it, right? And divide by x minus 5. So that's what I did. Bring down the 1. That's 5, 1, 5, 9. So it becomes x squared plus, geez, x squared plus, no, why is it saying x squared? X plus 1, yes, my apologies. Yeah. And right, and so here's the thing. Slight asymptote is an entity, right? When x is really large, what's happening to this expression? That goes away. If I let play a large number x, the 9 over x minus 5 just vanishes. So it looks like x plus 1, even though it's not truly x plus 1 on the left and right end, it follows the contours of that, right? So that's why slight asymptote. You ignore the remainder because the whole point of this, right? The whole point of this is to take the limit as x approaches positive or negative infinity. So it's y equals x plus 1 is your slight asymptote, which will look like this. Okay. We got x-intercept at 2. Y-intercept -4/5. Vertical asymptote at 5. Right? Actually, let's do green for that one. Let's do green for the vertical asymptote. Hold on, now I lost count. Okay, here we go. And I'll do a sign chart. What the heck? Let's do a sign chart. 5 and 2. Wait, what am I doing? I'm sorry, guys. That's at 2, 0. Why do I have a dot at 2, 1? That was dumb. Sorry about that, guys. Here we go. My apologies. So 5 and 2. Okay, go to the far right. Everything's positive, then negative and negative. The reason why there's no sign change at 2 is that's x minus 2 squared. There's no sign change there. And the graph will look like this. And this will be tucked in a little corner like that. And there's your graph. All right, we're cool so far? We're good? All right. Okay, a couple more and we're almost done. How's this? Why don't you guys try 7 and 8? I'll freeze the screen. We'll check in about 5 minutes. I'll do 7 right now. See how it goes.
Yeah. Pretty cold. This one's pretty.
Oh boy.
Yeah, that's weird. It's kind of weird, no?
It is weird. It's super weird. Guys, I have 2 holes here.
Do the x's cancel too? So 0.
Holes are at 1 and -3.
So you guys got x minus 1, 0, 1.
There's vertical asymptote x equals -3.
There's no asymptote?
No,
There's an asymptote. Wait, no, but that's a hole. Wait, so those holes are x minus 1. Wait. Holes at -3 don't matter. Yeah, but one is like the hole is like somewhere.
Oh, it's not even a hole because it's what?
Yeah, he agrees.
We talking about -3, right?
Yeah.
Yeah, right.
Oh, because it's not even.
Oh,
Okay.
is X minus one gonna be? What about?
That's it.
No.
There's no. And then one is.
X in the center.
No, it's actually lost out. Yeah. Okay, so when you consider that, wait, and the whole side. Is when these cancel, they're still between.
In the whole route.
Yeah. You observe about that.
And then it goes here. Stays
No,
on.
it doesn't. Does it not go?
Yeah. Oh, look, if you does it go over?
Mr. Yankee has zero.
Totally could.
Okay, here we go, guys.
Sorry, I forgot the one there.
My bad. My bad.
No, I have.
At 0, -16. Yeah, because you can't plug 0 into the original function, right? Yeah, it's just really hard to draw because it's so darn close to the origin. Yeah, my bad. Here we go. Ask questions. Ask questions.
Know whether it's on top.
Here or here?
For the asymptote, or like your both sides.
Well, Well, it can creep up and cross it. Okay, so actually, are you asking how this? Well, definitely this has to break the x-axis to get close to this out.
Yeah, but from above going down and below going up.
Well, it's gonna, oh, do you mean if it touches it, is that what you're asking?
No, like if this is like your asymptote, does it?
Which one are you talking about? Horizontal.
Horizontal.
Yeah, it will get close to it.
So like this, like, I don't know which.
Oh, it's gotta be below because it's gonna put the negative.
So it doesn't change it. It's above.
I don't know, it did change size.
Why do you have
one? To, back and forth.
Oh, so it's.
See if I want to change the.
So it'll never be going down.
Look, so it goes back down again, so it process out.
No, but it's like, that's going down again.
Oh, yeah.
That's enough to do, this is something starts with up, it's like after this, let's start down below.
Starting down below.
Yeah,
Never will.
that's gonna be a ceiling. That's a ceiling. Yeah.
You guys, one thing that just popped in my head. How do we know if this graph crosses horizontal asymptote? Well, I know based upon the things that we talked about, like the degrees and whatnot, that's gonna be y = 1/2. What you could do is set the equation actually equal to 1/2 and see if you can solve for x. I don't think we can, because if I cross multiply, I get 2x - 2 equals 2x + 6. 2x is canceled, so I can't. So I know it's not going to cross the horizontal asymptote. But one thing you could always do is set the function itself, or the simplified form of it, equal to the horizontal asymptote, and see if you can solve for the x value. If you can't, then it's not going to touch it. So, all right. Yeah. The graph stopped. It's an arrow. Yeah, it's your fault. No, just kidding. All right. Okay, last one. One of us. All right. Oh boy. Oh boy. You want to go back to the other one? Come on.
I have no idea.
Oh, after I simplified it.
It's not like 1 is 2x + 6. And the ratio, the degrees are both the same. You take the ratio of the.
Did it solve it for you?
Oh, wait, why is it 1/2? See, that's. Sometimes it can't be.
I mean, or that, or.
All right, last one, guys. Oh boy. This is one a little crazy. Okay, nothing crosses off. All right. Oh yeah. So you have x squared plus 2x plus 1, x plus 6, x squared plus x minus 12, x cubed plus 2x squared plus x. Oh, bless you. Are you sick?
Getting over a little cold.
Yeah, same here. You probably got me sick. That was Oscar. Yeah, it was Oscar. Yeah, you did. You did get me sick, dude. Actually, my kids probably got me sick because my kids are sick. So, all right. Anyway, yeah, I'm just doing all this jazz here.
Yeah. What do you know slanted now?
All right. Well, I know my intercepts, and let's get the intercepts out of the way. We know the intercepts are at -1 and 6, -1, -6. 2, 3, 4, 5. Okay. Asymptote at x equals -4. They are, aren't they?
Yeah.
Highly analytical. X equals 3. Y-intercept at -½ It's nice when you expand, you can see it more easily, but that does make sense. Sign chart will do. So at 3, everything's positive to the right of it. No sign change at 3. No sign change. No, there is no sign change at -1 because of the square, and then it's change sign after that. Right?
The street.
Yes, sir.
Also, wouldn't the horizontal asymptote just?
There's no horizontal. It's gonna be a slant asymptote instead. Yeah. I'm gonna do on the board.
They don't have space.
So that would just be x plus 8, right? Since you just take the height. Everything you just take the height.
Well, I don't know yet. Hold on. You might be right, I don't know. Okay, this goes in x times x squared plus x, so x cubed. Specify, please. So that's 7x squared plus 25x plus 6. That gives it 7 times. So it's actually x plus 7. At this point, I don't really need to go any further. So it gives plus 18x plus 90.
Can't you just like look at it?
It's irrelevant.
Yeah, this becomes irrelevant. So it's x plus 7, guys. That's just like asking x plus 7.
Oh, I just looked at the height.
Like,
You can think.
Um. Let's see. This is kind of crazy. Yeah.
I think that's how it looks, guys. So science starts critical. And it's helps. I was a little confused here, right? But for me to come back down again, I have to have another x intercept. That's supposed to happen. And plus, it is positive between these two values.
well,
Yes.
wait, does it necessarily,
It's not sort of four, but it's very nice.
does it get to cross that asymptote?
Yeah, it's what you can build. It's not the ends. It's not the ends of the graph. Guys, at slant asymptotes, just like horizontal asymptotes, we're all about the ends of the graph. As x approaches positive infinity.
That's all that. You can toy across the middle. 100% you can. 100% you can. Yeah, Ryan, go ahead.
What was the number sign chart?
Oh, it was basically what we
All these ones. -1, -6, -4, and 3. Okay. I do not. Here, I'll write it. -6, -4. -1. Yeah, right there.
Since the asymptote passes -7 on the furthest left, then would you not check what's on the left?
No, they don't care about that because it's not part of the graph. They don't need to. So yeah, Ario, go.
How would we know if it crosses that, slight asymptote?
Okay, great question.
And
So-
can I plug in x plus 7?
Yeah, great question. Here's what I do. I'm gonna set this equation equal to x plus 7,
And you solve it.
and you solve it.
Okay.
But if it's kind of crazy, if that's, I'm not gonna do that. That's what you do. All right, I think we're all done. Okay. So homework is just this right here. Now, I'll try to make an answer key for this. I don't have an answer key for it. I was gonna have you guys try that one website that that one former student came and talked to you guys. We actually met yesterday. Alex Summers, yes. And actually, we're talking about kind of build some sort of GPT together. I'm talking about some project, but regardless, his site's not working right now. So I don't know why I can't get onto it. Doesn't have you guys use it to figure out, hey, type it in, like, hey, what's the slant outcome of this? What is the blah blah blah? But I'll just make an answer key for you guys. So I'll just do it while watching the Niners game. Or maybe before if we get a chance. So but of course you always check Desmo, see how you guys do with the problems, right? Well, I'll try to do or let's see if I can find I could find one in the binder here. So anyway.